Section 13.2, line integrals, video 10. Before we move to the concluding topic of line integrals over a vector field, I need to make some comments about the orientation of curves relative to line integrals. Comments that I may have casually mentioned in previous videos, but need to give a little bit more definitiveness. In order to do that, I need to discuss what I mean by orientation. When you have a curve with an initial point and a terminal point, then the orientation is the direction that it travels from the beginning to the end. For example, see this black curve in here? If we call this curve C with its initial point on the left here and its terminal point on the right, then the orientation would be traveling along this direction. We're going to define another curve called negative C. It's the same curve, but basically you trace it out in reverse. In other words, the terminal point of C is the same as the initial point of negative C, so we're going to start over here. And the initial point of C is the terminal point of negative C. So negative C will end where C begins, and negative C will begin where C ends. And it still follows the same path, it just follows it in the opposite direction. In physics and engineering, orientation of the curve can be important. So we can discuss the relationship between the line integral over a curve depending upon its orientation. Now, there's three things to mention, well, two of them, because of the three, two of them are really the same. The first is with respect to arc length, and remember that the variable for arc length is s. Orientation is irrelevant. What that means is if we find the line integral of some function, we'll just say f in general, it could be in 2 dimensions or 3 dimensions, ds with respect to the arc length parameter, then the line integral over the curve going in one direction will give you the same answer as the line integral of the function ds with the curve going in the opposite direction, so negative c. And the reason for that is twofold. Number one, when you're measuring the change in arc length, it's always going to be positive regardless of the direction that you measured in. And number two, if you think about the origin of the line integral, where we have a curve in the xy plane and we lift up a fence and the integral finds its area, it really doesn't matter if we go forwards or backwards, that integral would still be the same, or rather the area of that fence would still be the same. So, if you're integrating with respect to the arc length parameter, ds, then the orientation of the curve is actually irrelevant. However, with respect to x and y, to x or y, orientation changes the sign of the line integral's value. So what does that mean? That means if we do a line integral over some curve, we'll call it C, some function dx, then that will give us the opposite. One second, I've got markers and caps all over the place. Let me get just a tad organized. All right, so let's try this again. If you evaluate the line integral of a curve with respect to x, then change the orientation of the curve, then you get the negative of the value that you got before. So when integrating a curve, when evaluating a line integral with respect to x, changing the orientation of the curve changes the sign of the line integral's value. And the reason for that is pretty straightforward. Although we didn't get into the formality, the formal definition of a line integral as a Riemann sum, I did mention that instead of using delta S's, we could use delta X's. If we were going from left to right, and our delta X was measuring how much our X changed, then doing the path in reverse would make all those delta X's negative because you subtract the second minus the first. So if this were an X-axis, then this value minus that value would be positive, but in reverse, that value minus that value would be negative. And therefore it would change the sign of the integral's value. And it's the same thing if you were integrating a line integral with respect to y. If you evaluate a line integral over some curve with some orientation c of some function dy, then that would equal the opposite of the line integral over negative c of f dx. So just keep in mind that orientation matters depending upon how you are evaluating the line integral. If you integrate it with respect to the arc length parameter ds, then the orientation actually does not matter. Whether you go forwards or backwards, you'll get the same value. But with respect to x or y, the orientation changes the sign of the line integral's value. So evaluating a line integral over a curve with respect to x would give the opposite of the line integral over the negative of that curve in reverse with respect to x. And the same thing with y, and I just realized this last x should be a y. So just something to keep in mind as you move through this section, and also if you move into the physics or engineering direction, keep in mind that there is a time when orientation matters if you're integrating with respect to a single variable as opposed to the arc length parameter.